You know that picture of the atom we all learned in school? A tiny little nucleus in the middle with electrons just zipping around it? It's an image that's been the bedrock of physics for like a century. Well, today we're going to look at a radical challenge to its very foundations.
What if those super elegant equations we all had to memorize were, from the very first step, kinda pushed to get the right answer? We're going to dig into a claim that says this is exactly what happened, and it's a story that starts over 100 years ago.
Now, just so we're all on the same page, we are diving deep into the specific arguments of one physicist, Mathis. And he's not just suggesting a few tweaks. He's basically saying we need to throw out a century of theory and start over with a brand new model. So let's see what his argument is all about.
Okay, so before we can tear the old model down, we have to make sure we're all clear on what it actually is, right? We'll start with that familiar picture, the Bohr model.
So the story goes something like this. Electrons can only exist in these very specific stable orbits, kind of like planets stuck in their tracks. These orbits are quantized, which is just a fancy way of saying they have set energy levels. And to jump from a high energy level to a lower one, an electron has to spit out a photon of light. And voila, that's what explains those distinct colored lines we see in atomic spectra. Simple enough, right?
All right, now for the fun part, the critique. According to Mathis, the first major crack in this whole foundation shows up in the very first equation used to build the entire model.
The derivation often kicks off with something called the virial theorem. It's a tool used for bodies in orbit, and it sets up this relationship between the total energy, E, and the potential energy, U. And that relationship is E equals 1/2 U.
And right here, this is where Mathis just hits the brakes. He asks a really simple, common-sense question. How can the total energy of something be only half of one of its parts? Now, physicists have a way around this. They define potential energy as a negative number here, which makes the math work out. But Mathis argues that on a basic logical level, this is the very first clue that something is being conceptually fudged.
And Mathis, he really doesn't mince words. He basically says this initial step just defies plain logic, and it's the first big red flag that the math is being manipulated to get a desired answer. For him, this isn't some small detail, it's a fatal flaw, right at the starting line.
And that's just the first domino. The critique keeps going. The next alleged fudge, according to Mathis, involves a really critical case of mistaken identity, all about momentum.
You see, the standard theory has to find a way to link the electron's properties to the photon it spits out. That bridge is Planck's constant, which helps you calculate the photon's energy. But it's how this bridge is used that Mathis says is the real problem.
So here's the play-by-play of what he calls a spectacular fudge. The math starts with the photon's energy equation. Then it gets expanded. In this new, longer equation, a momentum term, mv, magically appears, and then that momentum gets assigned to the electron that's in orbit. But here's Mathis's big aha moment. The equation we started with was for the photon, so he argues that momentum has to belong to the photon too, not the electron.
As he puts it, the change in the electron's momentum is the photon's momentum. He's claiming a deliberate switcheroo happened, where a property of the photon was taken and slapped onto the electron just to make the whole thing work.
So, if you're Mathis and you believe these two foundational pillars of the derivation are basically bogus, well, what do? He argues the only logical thing to do is scrap the entire thing and build a totally new model from the ground up.
And this brings us to his alternative. Instead of all this abstract quantum math, Mathis proposes a new, purely mechanical model, and it's based on a unified field that actually includes both charge and gravity.
And here it is. This is his replacement for the old Bohr equations. It's a unified field equation for the ground state energy of an electron in a hydrogen atom. Now, it looks totally different, but he claims it gives you the exact same correct energy value of 13.6 electron volts.
So let's break this thing down. M is just the mass of the electron, that's standard. But c squared isn't just a constant for him. It represents the real physical energy of the photon field. The number 9 is a multiplier he derives specifically for something in circular motion. And here's the really wild part. He takes a constant usually used for electricity, epsilon naught, and says it actually represents the proton's gravitational force, linking the two forces together.
So this creates a totally different picture of what's happening. The standard model just says, hey, the orbits are stable because they just are. But Mathis offers a physical reason. He says the electron isn't even orbiting the proton directly. It's orbiting a charge hole, a point of equilibrium. And it stays stable because it's constantly being energized by that external photon field.
Okay, get ready because this next part is maybe the most radical piece of his whole theory. It completely flips our understanding of what quantum levels even are.
So the standard view we all know says quantum levels are a property of the electron. It jumps between these different orbital shells. But in Mathis's world, no. The quantum levels have nothing to do with the electron. They're actually properties of the photon field that surrounds it. The electron never jumps anywhere. It just speeds up or slows down in its one single orbit because of changes in that field.
And this is really the mic drop moment of his entire argument. He claims the electron has no orbital levels at all. All those quantum numbers that physicists have been calculating for a century, he says they apply to the photon. From his perspective, quantum mechanics has been measuring the charge field this whole time, not the electron itself.
I mean, this is without a doubt a huge challenge to mainstream physics. It replaces abstract ideas with physical mechanics and literally rewrites the rules of the atom. And that leaves us with a much bigger question, doesn't it? In any field of science, what does it actually take for a century-old consensus to get a second look, or maybe even be overturned?